we continue looking at the basics of electricity. Introduction to AC. The supply of current for electrical devices may come from a direct current source or an alternating current source. In direct current electricity, electrons flow continuously in one direction from the source of power through a conductor to a load and back to the source of power. Now, some sources of direct current include the battery, the solar panel, and when you have a generator with a rectifier attached. The generator may be an alternating current generator, but the rectifier turns the alternating current to direct current. Let's continue. Voltage in direct current remains constant. DC power sources include batteries and DC generators. In allowing current in an AC generator, an AC generator is used to make electron flow first in one direction, then in another. Alright, this allowing should have been in alternating current. Another name for an AC generator is an alternator. The AC generator reverses terminal polarity many times a second. In most cases, it is 50 or 60 times a second. And the number of times a second is called the hertz. So on some appliances, when you read the nameplate, it might say 50Hz or 60Hz. You write the H in uppercase because it is someone's name. It's named after Hertz, a scientist. Electrons flow through a conductor from negative terminal to the positive terminal, first in one direction, then in another. So in an alternating current, you have current flowing left to right, then right to left, then left to right, then right to left, and so on and so forth, right? Let's look at the AC sine wave. Alternating voltage and current vary continuously. The graphic representation for AC is a sine wave. A sine wave can represent current or voltage. There are two axes. The vertical axis, the one that goes up and down, represents the direction and magnitude of current or voltage. The horizontal axis represents time. When a waveform is above the time axis, current is flowing in one direction. This is referred to as the positive direction. When the waveform is below the time axis, current is flowing in the opposite direction. This is referred to as the negative direction. Alright, so what you have happen is that at one point in time, the current is 0. Then it rises, increasing. So you might have a few milliseconds later, it's at, let's assume that the maximum is 5 ampere. It's at 1 ampere. Later on, it's at 2 amperes, 3, 4, 5. in one direction. This may be left to right. Then it goes down as time goes by. I'm saying milliseconds because it happens rapidly. As time goes by, it goes back down to 4, 3, and later on to 2, then to 1, then to 0. Still, it was going from left to right all along. Then it changes direction from right to left. 1 amp, 2 amps, 3, 4, 5 amps. Then later on it goes down to 4, still flowing from right to left. 3 amps, 2, 1, and then 0 amps. Then the process repeats itself. This covers one cycle. How you know that it covers one cycle is because you end up repeating the process. It rose from 0 upwards at this point. It's going to be doing the same thing here again. It is repeating itself. It's just starting to repeat itself, so it had covered one cycle. Alright? Now, a sine wave moves through a complete rotation of 360 degrees, which is referred to as one cycle. Alternating current goes through many of these cycles each second. The unit of measurement of cycles per second is the Hertz, H-E-R-T-Z, commonly written as Hz. That's a short form of writing it. In the United States, alternating current is usually generated at 60 Hertz. And I know that in other countries, for example, Jamaica, in England, it's generated at 50 Hertz. Now, many of the appliances, electrical appliances, are made in China and other countries, and they are not sure whether the exporters will take them to a country that uses 60 Hertz or to a country that uses 50 Hertz. So they make the appliance so that it can run on 50 or 60 Hertz. Now, single phase and three phase AC power. Alternating current is divided into single phase and three phase types. Single phase power is used for small electrical demands such as found in the home. So that type of power is found in the homes and offices. In fact, in most locations, in shops, plazas, in majority of the locations where you have a plug or lights, they use single phase. That's single phase power. You can identify that a building is using single phase power if you have, from the utility pole going to the building, 2 live wires and a bare or raw wire that supports them. The raw or bare wire without any insulation is the neutral wire, and those 2 insulated wires, usually black, wrapped around it, are the 2 live wires. In some cases you might have 1 bare wire and 1 live wire. Now, 3-phase power is used where large blocks of power are required, such as found in commercial application and industrial plants. So in factories and large buildings such as hotels, you might have three-phase power going to them. You can identify three-phase power from the fact that you will have 4 conductors going in. In older installations, you have red, yellow, and blue with a black or bare raw wire. In more modern, you have brown, gray, and blue. Those are the 3 live wires, and the bare wire is the neutral. So 3 live and a neutral will tell you that the power going into the building is 3-phase. 3-phase power, as shown in the following illustration, is a continuous series of 3 overlapping AC cycles. Each wave represents a phase and is offset by 120 electrical degrees. Right, that's the end of this document. Now remember, you should check out anything that you don't understand in this document by following the other videos that I link to, and I will also create separate videos further explaining some of the concepts found in this document. So thank you for watching, and I will see you in the next video.